We're in Physical Chemistry, Chapter 18, Section 3 now, continuing on quantum mechanics. Now let's talk about the Bohr theory of the hydrogen atom by Niels Bohr. So in 1913, Niels Bohr applied quantization to the hydrogen atom. Of course, he also looked at helium. So if you look at the spectrum from a lamp, you'll see that it's made of lines. And we get this formula: 1 over lambda is equal to r times 1 over n1 squared minus n2 squared. So remember, lambda is wavelength. N1 could be 1, 2, 3, 4, 5, and then N2 could be 2 or 3 or 4 or 5 or 6. And N2 has to be greater than N1. So R is the Rydberg constant. It's equal to 1.06776 times 10 to the 5th per centimeter. Per centimeter is wave number, so it's actually a unit of energy. And then see the spectrum handout. At first, spectral lines were empirical. So you get 1 over lambda is equal to nu whatever. Nu is the wave number. So wavelengths are in the visible range for those above numbers. So we get lambda nu is equal to c, where c is the speed of light and then nu is the frequency. So Bohr made postulates. Now 4 and 5 of these, number 4 and 5 were eventually proven false. But here's all 5 anyway. So number 1, energy of the hydrogen atom is quantized. These are discrete or distinct energies. So you have energy 1, energy 2, energy 3, etc. Each one of these is called a stationary state, or an allowed energy, or an allowed state. Okay, the second postulate: an atom in a stationary state does not radiate electromagnetic energy, or radiation. The third postulate: emission line spectrum results from the transition between an upper stationary state and a lower stationary state. Okay, 4, remember this is false. The electron in a hydrogen atom stationary state moves in a circular path around the nucleus. Of course, we know if that were true, then atoms would be flat, they'd be circles. So that's not true. And then 5, this one's also false. The angular momentum of the electron is quantized from de Broglie's theory. MVR is equal to NH over 2 pi, where N is 1 or 2 or 3, etc. Okay, so focus on this formula. 1 over lambda is equal to R times 1 over N1 squared minus 1 over N2 squared. We're going to call that equation A. Equation A is a difference formula. Equation A is an energy formula. The Planck's quantum of energy is incorporated into that. So E is equal to h nu, which is equal to hc over lambda. It's equal to hc times R times 1 over N1 squared minus 1 over N2 squared. That's the energy formula. Now, if you have a stable orbit, that means the forces are balanced. For example, here's an atom based on the Bohr orbital diagram. So you have the nucleus here in the center, and then the electron going in a circle on the outside. So the distance between them, of course, is lowercase r, radius, and there's a force of attraction between them, based on the electrical force, of course. So at any point, if the electron is here, its speed is going that way. It wants to keep going that way. But it's going to turn this way because there's a force pulling it this way. So that means if the electron is not going in a straight line, it's going in a curved path, it must be accelerating. Otherwise, it wouldn't be in an orbit. It would be going in a straight line. So Coulomb's law is that force is equal to z e squared over r squared. So remember, E is the charge of just one electron or proton. Z is equal to 1 for hydrogen. Z is the atomic number. R is the radius again. And then the units work out better if you use CGS units. Now let's talk about centripetal force. Force, of course, is equal to mass times acceleration, which is equal to mv squared over r. So v squared over r, that's the acceleration that the electron is experiencing as it goes around the nucleus. So we get z e squared over r squared is equal to mv squared over r. That simplifies to mv squared equals ZE squared over R. We'll call that equation 1. So remember, the E total is going to be equal to the kinetic energy plus the potential energy. So that gives us the energy total is equal to 1/2 mv squared, that's the kinetic energy, plus minus Z times E squared over R, that's the potential energy. And that's equation 2. Now we have a minus sign because the electron and the proton, they have opposite charges. So that's to show that it's an attractive force. Now let's substitute equation 1 into equation 2. That gives us the E total is equal to 1/2 ZE squared over R plus minus ZE squared over R is equal to minus 1/2 ZE squared over R. We'll call that equation 3. Now we get the E total is equal to 1/2 mv squared plus a minus mv squared, or just equal to minus 1/2 mv squared. Call that equation 4. Now this quantity, mass times the velocity times the radius, that's the angular momentum of the electron as it's orbiting the nucleus. So mvr is equal to nh over 2 pi. And then h bar is equal to h over 2 pi. So this is an angular form of the same number. So we get mvr v is equal to ze squared from equation 1. So we get nh v over 2 pi is equal to ze squared. We're going to solve that for the v. So we get v is equal to 2 pi ze squared over nh. That's equation 5. So what this does is it lets you calculate the speed of an electron in a hydrogen atom. So in the first orbital, that gives you the, well, n is equal to 1, and then the velocity is 9.4 times 10 to the negative, or 10 to the 7 centimeters per second, or about 587 miles per second. So remember, the speed of sound is about 0.2 miles per second. So the electron is going really fast, but not the speed of light, of course. Substituting equation 5 in equation 4, we get E total is equal to minus 1/2 m times 2 pi ze squared over nh, all that squared. And that's equal to minus 2m pi squared z squared e to the 4th over n squared h to the 4th. No, h squared. So everything on the right side of that equation is constant except for n. N could be 1 for the first orbital, or 2 for the next one, 3 for the third, etc. So En is equal to minus 2.18 times 10 to the negative 18 joules over n squared. And of course, 1 joule is equal to 10 to the 7 ergs. So again, it's easier if you just use CGS units. So E1 is equal to minus 2.18 times 10 to the negative 11 ergs. And that's equal to 2.18 times 10 to the negative 18 joules, or minus 13.6 electron volts. And then energy level 2, again, this is only for a hydrogen atom. This is minus 5.45 times 10 to the negative 19 joules, and that's equal to minus 3.40 electron volts. Or you have energy level 3, that's minus 2.42 times 10 to the negative 19 joules, and that's equal to minus 1.51 electron volts. So as the N increases, E gets less negative. So as N approaches infinity, the energy approaches 0, which means that the electron is no longer bound to the nucleus. It's just a free electron. 1 electron volts, remember, is 1.60 times 10 to the negative 19 joules. EV is electron volts. And also EV is 1 electron volt is 8,066 wave numbers per centimeter, I guess how you'd pronounce that. MVR is equal to NH over 2 pi. That's angular momentum. So V is equal to NH over 2 pi MR. We're going to substitute that back into equation 1. So we get M times NH over 2 pi MR squared is equal to Z E squared R. So we get R sub N is equal to N squared H squared over 4 pi squared MZE squared. Now we get H squared over 4 pi squared MZE squared is equal to A0 is equal to a constant. And that constant is 5.29 times 10 to the negative 9 centimeters, or 0.529 angstroms. A sub 0 is Bohr's radius. For n equals 1, the constant is 0.529 angstroms. So R sub n is equal to 0.529 angstroms times n squared. So here's energy levels. So we have energy level 1, 2, the amount of energy 2. So the difference here is h times nu in this case. So h nu is equal to E2 minus E1 is equal to minus 2m pi squared z squared e to the fourth over n2 squared h squared. And that's equal to minus 2m pi squared z squared e to the fourth over n1 squared h squared. So we can factor that out and just say h nu is equal to 2 pi squared mz squared e to the fourth over h squared times this quantity minus 1 over n2 squared plus 1 over n1 squared. Then divide by h, and we get nu is equal to 2 pi squared mz squared e to the fourth over h cubed times the quantity minus 1 over n2 squared plus 1 over n1 squared. So nu is equal to c over lambda. So 1 over lambda is equal to nu over c. So 1 over lambda is equal to 2 pi squared mz squared e to the fourth over h cubed c. All these are constants, times minus 1 over n2 squared plus 1 over n1 squared. So that we define the Rydberg constant, capital R, not to be confused with the gas constant or anything, 2 pi squared m z squared e to the fourth over h cubed c. So 1 over lambda is equal to r times 1 over n1 squared minus 1 over n2 squared. Now that formula turns out to be correct, even though it was derived based on two false assumptions. So then Heisenberg threw in a monkey wrench.